Welcome to Real GMAT Problems, episode 11. Doing real GMAT problems is an extremely effective way to improve your scores, so let's go through some more examples together and help you get to the next level. We're going to walk through 4 examples today of actual past GMAT questions together. I usually do 3, but I got cut short for a few reasons last time, so I'm going to do my best to make up for that today. And the problems that we're going to go through are from the 11th edition of the official guide for GMAT review. You can web search any of these if you'd like to follow along visually, but I know many of you won't be in that situation, and that's okay. Just so you know, the 11th edition of the official guide for GMAT review is out of print right now. And that's partly why I'm going through these questions from that book, because that way, if you purchase this year's official guide, which you should, and I highly recommend doing so, there shouldn't be any overlap between the questions that we're going to work through here and that book. So I guess this is kind of like a non-spoiler alert. This won't spoil the current edition of the official guide for you. Having said that, I'm very hopeful that a lot of what I'm going to talk you through today will help you with those fresh questions that you'll see in the modern version of the official guide. The official guide contains retired problems that have appeared on actual past GMAT exams. So it's really helpful because someone somewhere saw that question on a real test. And these questions are the best way to simulate what test day is going to feel like. So again, I recommend engaging with the questions that I'll go through here and also engaging on your own with the current edition of the official guide, where again, you'll hopefully be able to take what I teach you here and get even more comfortable executing on it. Quick side note, all of these questions from the 11th edition are also on Khan Academy. So if you want a different perspective on how to solve them, that's there for you. Having said that, Sal's approach, I don't always agree with, as you'll see. And so I'm here to give you a different perspective on what I recommend. A lot of what he does is just like talks you through the problem, but there isn't a lot of context given as to like how to best strategize for the official exam. So it's not that there's no value there. There obviously is, but it's just a different perspective, if that makes sense. Now, what I'll do is I'll read you the problem and I'll give you a chance to work through each solution on your own if you want to. And then I'll discuss my thoughts on the problem and any recommendations for what takeaway should be from each one. I also recommend pausing after I read through each problem and at the very least just thinking about how you would have solved the question. You might not be able to execute on all the steps in your head if you're on the go, but see how far you can get with the mental solution. It's a really good workout for your brain. If you are on the go, but you do have access to pen and paper, like if you're on a plane or a train, that's ideal. Try to make some progress on the problem before we review and focus on good, clear scratch work habits. In general, you want what you write down to be clear enough that someone else can tell how you thought through the problem just by looking at what you write. It's totally acceptable to go back and audit your past scratch work and see if you're hitting that metric for success. And if not, that's a major unlock for you. If writing these down is not practical right now because you're driving or at the gym or something like that, that's fine. Just do your best to visualize what you would write down and how that would ideally look. For most of us, that's going to be 100 times more productive than just trying to do everything in your head. So here we go. This is problem number 34. Problem says, what percent of 30 is 12? What percent of 30 is 12? Option A, 2.5%. Option B, 3.6%. Option C, 25%. Option D, 40%. Option E, 250%. Take a moment. Now, definitely pause the episode if you want to grind on this a little bit, but I'm going to just jump right into the solution just in case you're listening and there's no like dead space here. There are actually a couple ways to do this question, as you might suspect if you've been following this series. Some of you are going to have a very intuitive approach where you might just write 12 over 30 and then reduce that to 2/5. If you're not sure how reducing fraction works, or it's just been a long time since you've reduced some fractions, we've got a lesson on how to upskill with that linked below. So it's in the description of this content. This is a great time to mention that it's very worth memorizing some common percentage and fraction equivalences. For example, 1 over 5 is 20%, 2 over 5 is 40%, 3 over 5 is 60%. That kind of thing that like if you took the time to work it out, you'd probably know. Maybe some of you already intuitively know this, but most of us are not going to have memorized that stuff on a deep level because we just haven't needed to in the past. So what I recommend is memorizing all of your thirds, fourths, fifths, eighths, ninths, and elevenths. So everything from 1 to 11, except your sixths and your sevenths. 1/6 as a percentage or 2/7 as a percentage, it doesn't really come up much on the exam. And you can always do long division if you need to in that moment. Having said that, the thirds, fourths, fifths, eighths, ninths, and elevenths, I really would recommend making some flashcards for those and study them every day until you couldn't forget them, even if you tried. They come up a good amount, and it's obviously beneficial for getting questions right if you can say like, oh, 2/5, that's 40%, and just like fluidly go back and forth between those. But it's also like a confidence boost and an energy boost in the middle of the test of like, yes, I know this stuff, I'm prepared, that I think has a lot of helpful psychological side benefits. So highly recommended. Now, next to word problems, percentages are one of the most common topics in the quant section. So for that reason, memorizing these should pay off maybe even more than expected. Having said all that, it's definitely worth knowing how to do long division of 2 by 5 in order to get 40%, which is the correct answer to this question. So if you want help with decimal and fraction long division, we've got an episode on the basics of that linked below for you as well. It is slower in most cases, hence the desire to memorize the above, but every once in a while you might need to just grind it out. And if you want to score above the 90th percentile, I think decimal long division is absolutely critical. If you're okay below 90th percentile with your final score, it's not a huge concern, and you could probably get by with just memorizing the above, but it would still help to know the long division route. So that's just like a quick hitter intuitive approach for some people. And if that's you, you don't necessarily need to do change what you're doing on this problem. If you just immediately are like, oh, 12/30 reduce, bam, great. But what if that first move of doing 12/20 is not intuitive or natural for you? Or what if you did it and got the question right, but you weren't like 100% sure it was right? You were kind of like, I'm pretty sure it's 12/30. Um, in that case, I'd recommend memorizing a little formula to help you with percent translation questions. So I'm just going to go through that real quick. The word what in percent translation problems always translates to a new variable, meaning it's a variable you haven't seen previously. If X is already mentioned in the problem and you see what, you want to make a variable that is not X. You want to make a new variable. Otherwise, you're going to have serious, serious problems with these. Again, what means a new variable? You are making the variable up. It is not a variable that exists in the problem already. That's critically important. The word percent in percent translation problems always means divide what was just mentioned by 100. As in, 20% always translates to 20 divided by 100. Or P% always translates to P divided by 100. So what means new variable? Percent means divide what just came before the percent by 100. Of, the word of in percent translations questions always means multiply. For example, what's 2/5 of 10? That means multiply 2/5 times 10. 2/5 of 10 is 4. Finally, the word is in percent translation questions always translates to an equals sign. Okay, so what means new variable? Percent means divide by 100. Of means multiply. Is means equals. Let me just run through that one more time. What translates to a new variable, meaning a variable you have not seen previously. Percent, the word percent means divide what was just mentioned by 100. Of means multiply. Is means equal sign. Highly recommend a flashcard for that, or whatever you like to do to memorize things, study sheet, whatever. Just make sure you're not like hearing it, and unless you have a photographic memory, just expecting you'll remember it. Usually repetition is required to really lock these things in. This little set of translations can really, 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 really help if you struggle with percent translations problems. So let's break this problem down and translate one step at a time using this method. So the question is, what percent of 30 is 12? So we'll start with the word what. That means a new variable. Let's call that P. I'm just going to write P down. The next word is percent. What percent? So that means divide P by 100. So right now written down, I've got P over 100 in a fraction. What percent of 30 is 12? So the next word is of. I'm going to write a little multiplication sign right to the right of P over 100. And then 30 is just 30. So I'm going to write 30 right to the right of that. Question is, what percent of 30 is 12? So I write an equal sign right to the right of 30. And then 12 is just 12. So what I've got is P divided by 100 multiplication sign, 30 equals 12. I got a nice little equation here that I can solve for P. Again, P over 100 times 30 equals 12. This is like a great no-fail, simple approach that will help you nail these translations every single time and increase your confidence if you weren't 100% confident that you were translating it right. And from this point, you can just use algebra to solve, and I'm not going to walk through that here. As you know, the answer is 40%. Now, if you're not comfortable solving equations and you need to brush up on your basic algebra skills, we've got a lesson on that for you linked below also. Now, if you're naturally good with percent calculations, again, there's no need to change what you're doing. You don't have to memorize that formula I just gave you, but if you end up struggling or you just want a simple little system for those kinds of cases, now you have one. As always, if you have any questions on what I'm talking through here, you can reach us anytime at the GMAT strategy on current social channels via DM, or you can email us. We are contact, CONTACT, at thegmatstrategy.com. All right, so I'm just going to try to bang these out because I'm trying to fit 4 problems into like my 3 problem time span today. So it's a good little challenge for all of us. Let's see how I can do. Let's do problem 35. Feel free to pause if you want to make some notes on the previous problem. When you're ready, this problem says if 1.5 divided by 0.2 plus x equals 5, then x equals what? Okay, so let me just talk through that fraction. Question says if 1.5 and then fraction bar below 1.5, underneath the fraction bar, you have the combination of terms 0.2 plus x. So imagine 1.5 divided by, in parentheses, 0.2 plus x. And then that fraction is equal to 5. And the question's asking you, what is the value of x? Option A, negative 3.7. Option B, 0.1. Option C, 0.3. Option D, 0.5. Option E, 2.8. Okay, feel free to pause if you want a little bit more time to grind on this. Highly recommend at least visualizing what you would write down. It's all about what you write down with these basic problems. Otherwise, you're introducing a ton of risk and potentially missing questions you know how to do. Now, if you are that 0.01% of people who can do all this in your head and never make mistakes, that's awesome. That's awesome. Don't change what you're doing, but that is very rare. Very, very rare. This is a great question to practice some fraction and algebra skills. In most situations, when you see a denominator on the exam, it's a good idea to try to get rid of it, usually by multiplying both sides of the equation by whatever is in the denominator. So that's going to be my first move here. I'm just going to repeat this, though. Multiplying both sides of equations by denominators, if done correctly, is a great high ROI default behavior. It rarely, rarely hurts to do that. Having said that, you will want to make sure you're really tight on your math basics because it's super easy to make a mistake. In fact, 7% of people choose option D here, which is not right. And we'll talk about why that happens in a moment, why a lot of people pick 0.5, which is not the answer. So let's go ahead and make that move of multiplying both sides by 0.2 plus x, since that's the whole denominator. This can take a little bit of getting used to if you're just used to dealing with fractions that are simpler, but all the same rules of fractions apply to more complex terms like 0.2 plus x. Also, if you need some work on fractions or algebra basics, again, those episodes are linked below. So feel free to pause this episode, listen through those, work through those, upskill, and then come back. This should make a lot more sense once you do. So one pitfall that I can see is failing to distribute on the right-hand side of the equation. So that mistake might go something like this. You multiply both sides of the equation by 0.2x, and on the left side, it might just be obvious that we're going to cancel that out with the denominator. So the left side doesn't just change. We'll just wind up with 1.5 on the left side of the equation. But on the right side, if you don't put parentheses around the 0.2 plus x, you might forget to distribute the 5 to both terms. And if that happens, you'd wind up with 5 times 0.2 and then just 5 times 0.2 plus x by itself, which is not right. That's not what we want to wind up with, but you might wind up with that. If you try to solve that, then on the left, you'd have 1.5, and on the right, you'd do 5 times 0.2, which, if you've memorized your fraction equivalences, is 1/5 of 5, so that's just 1. So on the left, we'd have 1.5. On the right, we'd have 1 plus x. You subtract 1 from both sides, and you'd end up with x equals 0.5, which is option D, which is the wrong answer. Again, 7% of people are doing that, which is way too much, everybody. We don't want to be those people. Now, it's okay when you're practicing to make those kinds of mistakes, obviously. Part of how we learn is making mistakes, but you do not want to repeat mistakes. Okay. Making mistakes is acceptable, but repeating mistakes should be unacceptable in the sense that you're doing everything you humanly possibly can to keep from repeating mistakes. Now, we're all human. Sometimes we're going to repeat a mistake. We just want to minimize that to the maximum possible extent. Making mistakes is how we learn. Repeating mistakes is how we fail. We do not want to do that. So, 7% of people go in this route. I mean, it's not an overwhelming issue, but I think it's fair to say that it's a very correctable problem. And if you want to go to a great business school, this is not a problem that we should be entertaining or accepting. So, a good rule of thumb is whenever you're multiplying both sides of an equation by anything, put parentheses around two things, what you're multiplying by and what's being multiplied. Okay. So in this case, I'd want you to put parentheses around 0 0.2 plus x, and I would also want you to put parentheses around the existing terms on each side of the equation. So in this case, that would be just 5. Now you might be thinking, dude, that's overkill. Why are you asking me to do that? Again, we want to have a 0% chance of making that kind of mistake. Those kinds of mistakes are the biggest reason people don't hit their dream quant scores. It's not that they don't know the material. It's not that they run out of time, although those are issues for a lot of people and you should address them for sure. But those issues are obvious to address. And so people end up putting like all their energy into that. And then they're like wondering why they don't get their quant score. It's like, dude, I can't help you if you're missing questions you already know how to do. So I'm trying to be as heavy-handed with these recommendations as I possibly can to save you from what I went through, which is 8 months of studying, and then my score went down. Like, you don't want that to happen, I promise. Okay, so you probably don't need the parentheses around the 5. But the point is to establish the habit of doing parentheses around both from the beginning, because if it's a habit, you won't need to think about doing it on test day. It'll just happen, and you'll be 100 times less likely to pick something like option D. So let's assume you do add the parentheses, or that you never forget to distribute terms. Obviously, like I said, if you're in that small percentage of people who never make mistakes doing stuff in your head, that's great. Then you would wind up with 1.5 equals in parentheses 5 times also in parentheses 0.2 plus x. And that makes it super unlikely you're going to forget to distribute. So let's distribute the 5 on the right-hand side of the equal sign, which would give us 5 times 0.2 plus 5 times x, which is the proper thing that we should wind up with on the right-hand side of the equation. Now you've got a couple options for 5 times 0.2. You can do some decimal long multiplication if you want. Episode on how to do that well linked below. That works great, totally acceptable. You may have taken my advice and memorized that 0.2 equals 1/5, like I mentioned before. Obviously, that works great. And either way, if you execute well, you should wind up with 1.5 equals 1 plus 5x. Now, at that point, you can use the golden rule of algebra, which is whatever you do to one side of the equation, you do the same thing to the other side, and you subtract 1 from both sides. On the left side, 1.5 minus 1 equals 0.5. And on the right side, 1 plus 5x minus 1 is just 5x. So we wind up with 0.5 equals 5 times x, which is correct. We'll just use the golden rule again, divide both sides by 5 in order to isolate x, which is what we want to solve for. And there are a couple paths you can take to compute 0.5 divided by 5. You can use decimal long division, which works great. Again, that's linked below if you want help with that. Some of you may intuitively be able to see that 0.5 over 5 equals 0.1. That's great if that's you. In this case, you might not need additional skill building. And then the final option is to transform 0.5 into a fraction, which is 1 over 2, and then divide that whole thing by 5. Some folks have an easier time doing computation with fractions and decimals, a lot of times just because it's more visual. And again, whatever you need to do to not miss questions, you know how to do. There's no style points on the GMAT. There's no like top 10 plays of GMAT on SportsCenter at the end of the night. It's like you either got the question right or you didn't. And if it's ugly, we can take ugly as long as it works. So as I've said before, there are no right or wrong approaches. It's all about what's going to work best for you personally. And I've found that people leaning into their strengths usually gets the fastest results. So I recommend investing the time to try a couple different approaches and figure out what you like. That'll really pay dividends down the line when you're under time pressure, because the more good decisions that you commit to in advance and back up with data, even if it's anecdotal data of just you being the only person in the data set, it's going to be a lot easier to execute those good decisions under pressure if you've pre-committed to them and realized that that is the right way that works for you. Now, Quick aside, if you're going for a super top score, like 95th percentile and above, then you want to be super fluid with every single one of those options I just walked you through. You want to be able to do it with a fraction. You want to be able to do it by memorizing it. You want to be able to do it with decimal long division. Like you are looking for mastery if you're going for a 99th percentile score. Again, the only caveat is if you're that person who never makes mistakes doing stuff in your head and everybody's jealous of you. So, good for you. That's awesome. So the correct answer is option B, 0.1. That's pretty much the long and short of that question. On the surface, it's a relatively straightforward algebra question that tests pretty fundamental skills, but it's also an opportunity to examine your approach to computation and figure out what's going to serve you best on more complex questions, which if you get those questions right, you'll definitely see. And that's that. So if you have questions, let us know. I'm going to skip over problem 36, which is a coordinate geometry question. The GMAT has changed quite a bit since the 11th edition of the official guide was published, and geometry isn't really tested that much at all anymore. So if you want to understand how the new exam is different, you can check out our episode called How the GMAT Works in 2025, and that's going to be linked below for you as well. Let's move on to problem number 37. This problem says if a positive integer n is divisible by both 5 and 7, then n must also be divisible by which of the following? We've got some Roman numerals here. So this is an interesting format of question where there'll be usually 3 Roman numerals, 3 options, and then the answer choices themselves are going to be like 1 and 2, 2 and 3, 1 and 3. So I'll read through those in a second. Let me give you the problem again, just in case. Highly recommend writing this down if you have that capacity. If a positive integer n is divisible by both 5 and 7, then n must also be divisible by which of the following? Roman numeral number 1 is 12. Roman numeral number 2 is 35. Roman numeral number 3 is 70. Option A, none of the above. Option B, 1 only. Option C, 2 only. Option D, 1 and 2. Option E, 2 and 3. All right, again, pause if you want some more time to work on this. This is a great refresher on some of the concepts that I was discussing last time. And I'll link that previous episode below as well if you'd like to check it out. Weirdly, there were some like tech issues with some of our platform providers there, so that episode might have come out a few days late. Sorry about that. Apparently there was a tech glitch on their side, but should be resolved. We've been in touch with them. Now, you might recall I strongly recommend expressing divisibility questions as fractions. And if you're like, what are you talking about? Then go back to the previous episode, and I'll talk you through like exactly what I mean by that. Additionally, I recommend expressing divisibility questions as fractions and thinking about them in terms of prime numbers. Okay, so again, if you're not sure what I'm talking about there, or you want a little brush up on that before I dive in, that previous episode's there for you. But if you've already heard that episode or you already know what I'm talking about, let's proceed. This question's a good example of the value of that technique. If n is divisible by 5 and 7, and I want to express that as a fraction, then I'm going to want to put n in the numerator. That's what's being divided. And I want 5 times 7 in the denominator, since that's what we're dividing by. So I would physically write that out. N, fraction bar beneath that, 5 times 7. I would also recommend writing equals integer to the right of that fraction, and that should really help with the analysis that I'm about to talk you through. So just visualize that if you're on the go. N over 5 times 7 equals integer. So as a quick recap, recall that when something is divisible by something else, I should be able to perform the division and get an integer result. That is the key. That's what divisible means. So let's think about what will yield an integer here. As long as n has a 5 and a 7 in its prime factorization, we'll be able to cancel 5 and 7 in the denominator. And for sure, we will get an integer. And that is like the concept that I was going long on last time. So again, if you want more help, that's there for you. If you feel comfortable with that approach, you can look at each option and just ask, does this have a 5 and a 7 in its prime factorization? Let's do that. Roman numeral 1, 12. No 5s, no 7s. Because all we know about n is that it has to have a 5 and a 7 in its prime factorization, we do not know for sure if n is divisible by 12. It might be. There might be tons of other prime factors in n. All we know for sure, though, is there's a 5 and a 7 in there. So let me give you an example. Prime factorization of 12 is 2 times 2 times 3. If n happens to be 2 times 2 times 3 times 5 times 7, which it could be, then it'll definitely be divisible by 12. But if n is simply 5 times 7, it will not be divisible by 12. The question is asking us what n must be divisible by, not what it might be divisible by. So we don't want to select Roman numeral 1. It's not guaranteed that it's divisible by 12. It just might be divisible by 12. That's not what we're being asked here. Let's contrast that with Roman numeral 2, 35. Well, 35 is just 5 times 7 if you prime factor it. So that is for sure going to divide evenly into n because we know for sure that n has 5 times 7 in its prime factorization. The problem told us that straight up. So whether n is just 5 times 7 or whether n is 2 times 2 times 3 times 5 times 7, it will be divisible by 35. So we're definitely going to select Roman numeral 2. Roman numeral 3 is kind of interesting. It's 70. If you prime factor it, you'll notice that that's 2 times 5 times 7. But all we know about n is that it has a 5 and a 7 in its prime factorization. So it could be 2 times 5 times 7, in which case it would be divisible by 70, or n might just be 5 times 7, in which case it would not be divisible by 70. So we can't say that 70 must divide n, only that it might divide n, just like Roman numeral 1. So that is going to lead us to answer option C. Now, alternate approach. You can just test numbers. It's a little riskier, but it's definitely viable. So let's quickly talk through this. Interestingly, this is a solution where you could just consider a few numerical cases. Really intuitive approach for some people. And if you like this, it's got a lot of upside. So let's say you read through the original question and it said positive integer n must be divisible by 5 and 7, and you immediately thought like, oh, let me try 35 as like an example. That actually works pretty well in this problem because you can see that 35 is not divisible by 12, it's clearly divisible by 35, and it is not divisible by 70. And you may have gotten to the answer pretty fast. Perhaps obviously that's super nice when it works out. And if it's intuitive for you to do it that way, that's great news. But you may struggle with this approach on more difficult problems. So here's my advice. Default to thinking of numbers if that is your natural state, and if that works well on the problem, or at least gets you some fast eliminations, awesome. You may even consider testing a few other cases if they aren't too hard to think of. Like for example, here you could have used 105 and like double checked with 105 and it still would have worked out. It's probably not as intuitive as 35, but theoretically it could have worked. Having said that, the number testing approach can be impractical when numbers get super, super large. Like if we had, for example, like n is divisible by 2, 5, and 7. What's guaranteed to be to divide n to the 17th power? That's probably not a situation where you're going to want to be plugging in numbers. So I would still recommend doing your diligence and understanding the theoretical approach involving the prime numbers that I was just talking through. And that's partly why I went long on that last time, rather than just saying, hey, plug in some numbers on these questions and, let me know how it goes. Which obviously sounds great for like a, slick YouTube short or something, but that's not the full story. So let's not try to pretend that something like that's going to take you all the way to the 99th percentile. Again, unless you're in that tiny, tiny category of like people who just are going to get 99th percentile scores almost no matter what they do, which is cool. So this way, if you understand both approaches and you get stuck testing different numbers, you'll have something you can fall back on, even if the number testing approach is your front line of attack, which is totally fine. I've seen that work really well for a lot of people. So that's that. Again, if you want a little bit more depth on that divisibility and prime factors way of thinking about it, highly recommend last week's episode, episode 10 of Real GMAT Problems. Again, just reach out anytime if you have questions on any of this. Let's see if we can squeeze this last one in. Lightning round. This problem says if 4 is one of the solutions to the equation x squared plus 3x plus k equals 10, where k is a constant, what is the other solution? Let me read that again. If 4 is one solution of the equation x squared plus 3x plus k equals 10, where k is a constant, what is the other solution? Option A, -7. Option B, -4. Option C, -3. Option D, 1. Option E, 6. Great opportunity to put your quadratic equation factoring skills to the test. If you want help learning or relearning how to factor quadratic equations, we've got a math basics episode on that exact thing linked for you below. Let's assume you know how to factor quadratic equations. If you don't, pause and listen to that episode and then come back here. Think about the first piece of information we're given. They're already telling us one of the solutions. It's 4. So if we were going to make the typical moves of setting the quadratic equal to 0 and factoring, we had already set up the 2 sets of parentheses, we can just fill in x minus 4 as one of those sets. So the way that would look would be in parentheses x minus 4, because one solution is definitely 4. And recall from the math basics lesson I just referenced, or your general knowledge of how to factor quadratic equations, that we need the numbers in each set of parentheses to add up to the coefficient of x in the original quadratic equation. Note that you can completely ignore the k and the 10 with this solution and focus only on the fact that 3x is in the original equation. So what number would add with -4 to make 3? Remember, when factoring a quadratic equation, you can set the equation equal to 0, create 2 sets of parentheses, so you have like parentheses x blank, and then another set of parentheses x blank, and then equals 0. And then you're going to fill in a number next to each x in the parentheses. If you don't know what I'm talking about, please just listen to that math basics lesson real quick. It's a quick hitter. You'll be up to speed in, well, I can't say in no time, but relatively quickly. So those numbers need to add to the coefficient of x in the original equation. Because we have -4, we know we need to sum that with another number to create +3. Hopefully you're thinking that number is going to be 7, which is correct. So if we had the fully factored equation, we would have x minus 4 in parentheses times x plus 7 in parentheses equals 0. That means the other solution, the other root of this quadratic would be -7, because recall that each root has to make the whole left side of the equation equal to 0. And that's our answer, A, -7. Went through that a little quickly. That's what I might call the logical solution to the problem, because we're not plugging and chugging the way that we typically would in an algebra problem. Instead, we're just using algebra to make a little bit of progress, but really it's like what I'd call like algebraic reasoning or like algebraic logical deduction to figure out what the answer might be rather than fully solving for the answer. And that can be a good, fast solution if you're comfortable with the theory behind the question and you're comfortable with how factoring quadratics works. That's why I was harping on that previous math basics episode. But if that approach just isn't concrete enough for you, that's fine. There's a good alternative here that we'll walk through right now. You can just like plug and chug here. So this is a great move when you're given an equation and given one of the values that quote unquote works in the equation. In this case, we know that x equals 4, and that's going to make the equation true. So we could just plug in 4 for x and solve for k in the original equation. Let's do that real quick. That would be 4 squared plus 3 times 4 plus k equals 10. That's going to be 16 plus 12 plus k equals 10, or 28 plus k equals 10. If we subtract 28 from both sides, we would get k equals -18. Then we can plug that into the original quadratic and factor it. Okay, so the way that would look would be x squared plus 3x minus 18 equals 10. We want to set it equal to 0, so let's subtract 10 from both sides. X squared plus 3x minus 28 equals 0. Then we make our 2 sets of parentheses, and we just need 2 numbers that sum to 3 and simultaneously multiply to -28. If we search through the factors of 28, we'd wind up with 4 and 7, and we can deduce we would need -4 and +7 in order to sum to +3. Now you could rewrite that if you want to as x minus 4 in parentheses times x plus 7 in parentheses equals 0, and then you would know the other solution should be -7. So again, if that first solution I went through is a little too abstract for you, this one works great. But if the first solution makes sense, I would recommend it because it probably will be faster and it has fewer steps. And fewer steps usually means fewer opportunities to make a mistake and miss a problem I know how to do, just by and large. Now, I do want to give a caveat there. As I said last time, there is no right or wrong with these approaches. Just experiment and build the set of methods and solution paths that works best for you, and you will be on the fastest path to GMAT success that you can be. Once again, if you have any questions on anything I've presented here, you can always reach us at the GMAT strategy online via DM, or you can email us at contact@thegmatstrategy.com. I also want to briefly mention that if you're struggling to see the progress that you want to see in your prep, or your current plan is just taking longer than you want it to, we do offer a complimentary strategy call where we'll assess your current progress and make some recommendations about how you can improve your approach and see results faster. If you're just starting out, we can also set you up for success from the start with a tailored study plan. Call's free. There's no obligation to buy or do anything we recommend, and there's no catch. It's not like we're trying to trick people into doing stuff. It's absurd to me. We are actually just there to help you. You should leave the call with at least a couple great options of how to proceed. We're delighted to be able to offer this service. It's something we've been working toward on our service roadmap for many, many years, and we finally can do it. So we're really excited. But if it's not for you, or you're already seeing the exact kind of success you want to see with the test and your prep, that's totally cool. And it's just really generally not required to have a call with us to see success, perhaps, obviously. But it's there if you want it. Having said that, if you think you might want to work with us directly or learn whether any of our products or programs could be a good fit for you, we're happy to explain that on the call. But if you're not interested, we won't even go over those options, and we can just help you out with another program that you feel is a better fit. Our program tends to be a good fit for people who want the fastest results possible. That's what we specialize in. Or you've struggled to see results with other providers, like reversing score drops is something we've got specific products and programs for. So if you've seen scores drops or you're struggling, then please let us know, and we'll be more than happy to get that turned around for you, whether we end up working together or not. So if any of the above sounds good, just please head to our website, check out our free video where you can get a feel for our style. If at that point you're still interested in speaking, you'll be able to share a little bit more about your situation in a forum and book a call from there. As always, my greatest hope is that this material will make your studies as easy and as painless as they can possibly be. If you want more tips and strategies for optimizing your performance on the exam, please head to our website, thegmatstrategy.com, which is linked in the description of this content, and check out our free video on how you can reach your dream GMAT score in half the normal time. Would love to save you some time with that. In the meantime, this is a regular show, so please subscribe and please stay positive and stay consistent with your studies. Talk to you all soon.